So I'll start the recording, and we'll go ahead and start the session. I realize there's only 2 of you in here today, but that's 2 important ones that for me to talk with. I do 1 session all semester with just 1 student. Well, at the start of the semester, I had 2, I believe. The first couple of weeks, then 1 dropped out, and that left 1, and so I met with 1. So in any event, we probably will have a few more join us in a minute or 2, but we'll see. Next week, the Monday session that I do for this class each week will be on Wednesday at 10 o'clock instead of Monday at 10 o'clock. So I'm doing my Monday sessions next week on Wednesday. So I will be off campus on Monday. I'll be online throughout the day at different times, but I'll be off campus for it and trying to do it with the things I've got going on and not exactly sure where I've moved it to Wednesday. This session on Tuesday will be Tuesday next week. Next week is the last Collaborate sessions for this semester. The following Wednesday, May the 4th, is the last day of the class. Anything that you're going to turn in has got to be turned in by the end of that day, except for your finals. The finals will be due the next day on May the 5th. And graduation actually is that evening, and I'm supposed to be at it. And then I've got a meeting that afternoon according to the schedule about statewide curriculum. So that will be going on. Tomorrow morning, just for your information, I will be late getting here on campus. I'll be at a leadership walker project where we're fixing up the kid area for the library, for the Lafayette Library, planting a tree and putting some things for the kids to do up around in the little play area. But we should be done in a couple of hours, and then I'll come on to school at that point. Actually, I'll run home, change clothes, and then come to school, and depending on how much I played in the dirt, which shouldn't really be at all, hardly at all, might have to grab a quick shower on it. But so I'll be doing that tomorrow morning and be a little bit late, but then I'll be here, and I should be here, as far as I know, all the rest of the day tomorrow. Thursday, I'm not exactly sure how my schedule is going to work on that. I will be online at different points during the day. I may well be leaving lunchtime or so because there's an event I want to attend in South Georgia that evening, but I'll check in online at a couple of points in the afternoon, also answer emails. And I've got training tonight and Thursday night online with the A+ Train the Trainer for the new A+ exam. I've got to make up the session for last Thursday, listen to the recording on it. Those run 2 hours each. I did last Tuesdays, and now I've got these coming up, so I've got to work on that one. So we'll see how all of this all works out for me. And then as far as y'all's grades, I'm going to try to this afternoon, or for sure tomorrow, hopefully start transferring the grades for everybody I've got permission slips for from Cisco back to Blackboard, and then I'll work on the reversal on it. But if I can get your test grades moved over, that would be good. And so I'm going to be trying to work on that this week too. So that crammed into there too. But like I say, we're down to the end. We are in chapter 16 this week. Next week, if I'm remembering the calendar correctly, we've got chapter 16 and 17 next week, chapter 15 this week. Next week, for your assignments, you actually have a couple of extra days and the test, because the last day of the semester is Wednesday the 4th. So I don't have stuff to do on Monday except for discussions, which those of you watching live don't have to worry about that one. Well, if you watch next week's live. that it is due on Monday, but the assignments and tests that would have been due on Monday, not this coming week, but the following week on May the 2nd, are actually due on May the 4th. So you got 16 and 17 to do then, but you got 2 extra days in there. The other part is 16 is security, and we'll talk about it next week. And 17 is building a small network, and there's really not a lot of new stuff in there for you. It's really putting together the book for you, and looking at building a network at home or in a small office where it's just a few computers. All right. Any questions on all of that? The other one is registration is still going on. If you have not registered for summer and are going to come summer, you need to do that as soon as possible. So we'll work on that one. So that's just a reminder on that. And I think that's all the announcements. Chapters, is there any questions on any of that or anything else? And it can be on previous stuff or whatever. Final exam will be about twice as long as the regular test. You will have it available from April the 30th, which is a Saturday, through May the 5th to take it. And you'll have twice as much time to take it in. So you get an hour and a half on it instead of 45 minutes, and it's about twice as many questions. Course feedback, I think, is available now. I'll have to double check that, make sure it still is available. I had it available, but they only let me open it up for like 7 days at a time, so I'm not sure if it's still available or not. But it will, before you can take the final exam, Cisco will make you have completed the course feedback at Cisco. There is a course evaluation that got emailed about from the college also, and I would encourage you to complete that one too. I do look at it, and I know my dean does look at it some too. I look at the comments in particular deeply. I've made changes in my classes based on those. These collaborate sessions actually are partly off of that, and having them in the daytime is off of comments, because I used to do them in the evening originally, and I gotten the idea from some classes I was taking. So I would encourage you to do those. The course feedback from Cisco, it's like 7 questions, and it's not anything really to it. I never even see the results of it. If you haven't done the Try Hack Me assignment, get it done and get it in. And need it as soon as possible. The deadline for it actually is Saturday, April 30th. I really wanted it a whole lot earlier, but I didn't want to. I knew some of you were going, you had to squeeze it in or whatever, so I was flexible on it. The other one is, if you haven't finished the packet tracer course that's sitting out there, please get that one done. Next semester, that completely changes. Cisco has completely rewritten that course, and I can't even use that one anymore. Their suggestion was, because we found a couple of errors in it, was just make all of y'all start all over again and create a new course using the new one and put everybody in it and make them all do that. And I'm going, no, y'all have already done on this, and I'm not going to make you go back and go through stuff all over again. I'm not sure where they was coming from, but so that's that. So now in chapter 15, that we're looking at the application layer is what the title says. Now that's application layer in terms of the TCP IP model, not the OSI model. And there's Whitfield. We're looking at the session, presentation, and application layers on the OSI model. So they just simplified themselves on it. So they give you a brief little things about the 3 layers to start the chapter off, and that's about all you usually find in any book you read on the OSI models. Usually you do see these 3 layers combined, and that you won't see a lot of material on them. You'll see some, and then the rest of the chapter we're going to be looking at protocols that are used up here on these layers, and talk about those real briefly, because actually most of those we've talked about earlier in the book. And I'm more than willing, I'm going to stay brief as I mention them, but if y'all want me to go into more detail on them, I'll be glad to. So if you do, just stop me and tell me, and I'll do that. Another name to add. So they mentioned about the application layer. Big thing about the application layer to remember is the application layer is not the application. That was the one that confused me for a little bit about the application layer. The application layer links the networking stuff, things that we're doing to put stuff onto the network, which the networking model does, and that we've looked at all semester, with the application. So when you go to send it and say you're going to use the network to send it, it leaves the application, goes to the application layer. And so that's the whole object of the application layer, just to link the networking things to the application. And likewise, when it comes back up, it hands it back off to the proper application. They're going to be exchanging the information between the two things, between the networking area and the specific application it belongs with. So that's the application layer. The presentation layer has got a couple of things it does. When stuff is sent from the application to the networking, the presentation layer will take that file or that information, that data that's going to be sent, which basically is a file, and it's going to convert it from the format it's in into a format that will work for networking. So it's going to do a conversion on it, do a little bit of work on it to convert it from like an Excel file into a format that it can then, the layers below will be able to work with to send across. And then at the other end, when it gets back up to the presentation layer will change it back from being in a network format back into the format it belongs in to hand it off to the application layer to hand it to the application. That's one thing. Second thing is the application layer also does compression and does encryption. Now there's some other places we do some encryption also down through there, but this is where it can encrypt the data, because all we're working with is the data at this point. We've not, remember, we're up above layer 4 where we broke it into segments. So we're talking about the whole chunk of data at this point. It could compress it. That's one of the things that can be done on this layer is compression. And remember, compression is just where it squeezes into a smaller file. Ways that y'all are familiar with it is things like zipping files is what you've probably heard about before. This isn't using your zip file programs, but it's using a networking method to compress the files. Second thing is it can encrypt the files on this level too. And then that makes them protected because they're using some type of encryption. With Windows, and I'm not sure with other applications or not, but I ran into this when I was getting to my MCSE, is that Windows itself, now you can use other applications to get around this, and that, like I say, encryption and encryption can occur lower down also. So, but within Windows on this layer, you cannot encrypt and compress a file. So if you're going to use Windows to do it, and remember you can go in and check boxes to choose on that type of stuff and things, you can't both encrypt and compress. The reason is because basically they're both doing the same thing, and that it goofs it up some. It's sort of like you really do not want to do that anyway, and that, even if you can. But the big thing is you don't want to usually try to compress an encrypted file or encrypt a compressed file. For a simple reason, they're both doing about the same thing, and it can cause some problems to it when you're doing the same thing again. Or like trying to compress a compressed file. Well, yes, you can run programs on that, but sometimes you'll end up with one messed up file on it, because then it's got a hard time trying to figure out the compression that the compression did, and that gets confusing. So, but compression and encryption would be one of the things, two of the things that the presentation layer does. The session layer, if you look in your materials they gave you, they give you very little information on that one. As a matter of fact, they've got to start off the set one little paragraph about it. That hardly even tell you're talking about session. So there's just a few lines on session. Yeah, I'll come back to that in just a second, as I explain this. But the session layer's job is to create the connection between the two devices and then to disconnect it. So all they're going to do is they create the connection, and then they maintain it and they do the disconnection. Now, TCP, remember, did a much more stronger connection on the whole thing, but this layer, its job is just to make a connection between the two and maintain it, and then disconnect on it. The example I used on it, which is what Whitfield's mentioning right here, is that the example I was taught about what the session layer does is to think about it like a secretary to a CEO. And I'm going to use Whitfield since Whitfield posed the question. That let's assume Whitfield and I are both big CEOs. We're CEOs of these really huge companies, and we each make a couple of $1 million a year. Whitfield, when you get that job, remember, hire me as your assistant CEO. And we're both these big CEOs. Well, if you think about what you know about these big CEOs, they don't normally pick up the phone and call each other. It's just like the President of the United States does not normally. Now, we've had some differences on this slightly, but the President of the United States normally does not pick up a phone and directly call somebody. That if the President of the United States wanted to call Whitfield and ask him for some advice, he wouldn't pick up the phone on his desk and call Whitfield about it. Yes, he does have a phone there that he can pick up and call one person directly, who will answer on the other end, and there's no dialing involved or anything. Just pick it up and it buzzes to the other one and he answers, and that's to Putin, which is that red phone in the Oval Office, to hopefully prevent a nuclear war from occurring. But the CEOs, normally, they don't do their own calling. What do? They tell the secretary that they want to talk to so-and-so. So if Whitfield decided he wanted to call me and us to set up to play a game of golf next week, and maybe complete that he's going to buy, his company's going to buy part of my company that for $7 million, that he tells the secretary he wants to talk to Dr. Watt. The secretary then places the call to me, but the secretary is not going to get me. Who's going to answer the phone when the secretary calls my office? That's a question. My secretary, correct. Okay. I never even noticed secret was in secretary. But Cortez, you just taught me something right there. That's interesting. The secretaries are supposed to keep secrets. So his secretary calls my secretary. They're doing what the session lawyer does, because my secretary answers and tells his secretary, yep, Dr. White can talk to Whitfield. And so then they pass the call off to him and me. Okay. Now, we'll go through, have our telephone call. The secretaries aren't in on the telephone call normally. They could be, but most of the time they're not. But they may be to take minutes or whatever of it. And then we get to the end of the phone call, and we've decided we ought to go play golf next Tuesday morning. And we're both early risers, which I really am not. And that we're going to meet out there because we can get that he said he can definitely get us on the course at 7 a.m. But we're going to start playing as soon as the sun comes up. And I'm not a golfer. I've only played like 5 or 6 times, but I think I got 3 trophies for it. 1 for being last place. The other 2 for being on the correct team. And you choose your teammates carefully. Actually, my teammates chose me because they knew they had a good team, but they had to have a 4th person. So anybody did, and I was anybody. So then we'll hand it back off to our secretaries, tell them to make sure our calendars are clear for us to play golf then. And so our call gets handed back off to them and whatever else we had decided on. So if I did decide to sell that unit of business to him, that we got that and tell the secretaries too. And then we're off. The secretaries at that point are still connected. They verify everything's correct, get it on our calendars, and then they hang up, and that ends that call. That's what they have done there is similar to what the session lawyer does. They actually initiated the call, they terminated the call, and in the middle of the call that they may have had to do something to making sure the call stayed connected or whatever, or that I may have buzzed my secretary in the middle and said, I need this folder about such and such, or asked, am I really clear Tuesday morning to play golf? So and secretary, if you notice, starts with the same letter session does. And that was an emphasis my instructor threw at us, was to help us remember about the session lawyer. And that's all the session lawyer does. You're not going to see anything else about the session lawyer out there. Is that it establishes, maintains, and terminates the connection on it of the session. And so that's what happens there. Whitfield, did that answer your question? Okay. Because I try to, when that was explained to me, that made sense to me. And so I try to use that example in my examples because I was going, it makes sense. So let's use it. Because even though probably none of us in my class, I have not, and probably none of my students have ever been in that type position of either being that CEO or even being that CEO's secretary. We all have a understanding of how that's the way the world works up on that level. And we all probably have at least a little bit of wanting to be up there on that level, but some of us may not want to be on that level because of the stuff on it, but we probably all wished we could make the money that goes up there. And those secretaries tend to make good money too. Not as good as the executives, but they usually have good salaries as secretary to the CEO. Because back to what Cortez put, you want a good secretary that's going to keep secrets of what they learn about what the company may be doing, or even where you may be looking to go work for another company or whatever, to keep all of that information secret. So the secretary is extremely important too. Yeah, Deidre.
So I thought the transport layer was responsible for maintaining the conversation. I'm just trying to understand the difference between the two. So the
Okay,
go ahead. I'm sorry.
this where we're talking about here, the sessionware is in general for any of the network. Now, it's not making sure that the other end is actually there. Um, so it gets a little tricky on that part, but it's the part that if there is a session across there, its responsibility is seeing that the stuff can be sent out and that the other one is there. But it's not doing that connection oriented approach that we talked about on TCP, because you remember UDP comes underneath this also when it gets down to that, where it's getting more specific down there. But at this point, all it's doing is doing it in very general terms of establishing whatever type session needs to be established. Now, if you're going to use UDP further on down, obviously it's not actually building and holding a connection across there the whole time or whatever. It's just making sure the stuff's there and that making sure that it does get sent. But it's doing it in very general terms on this layer. When you get down to where you use TCP that we talked about last week, I guess it was, that is looking very specifically machine to machine and making sure the connect, and part of it is making sure the connection stays connected. On this layer, it's just making sure that you're really connected into there and stuff, into your networking, and that it's aware of the other end. But you may not actually have a connection physically to that other machine. But it's making sure that there is in general on it, because we don't even have addressing at this point on it. So it's doing it in very general terms on this layer, and I'm really not, at times I wonder why we even got this layer in there, okay? Which I think is partly why TCP sort of dropped the layer out of there and consolidated it, okay? But keep it as that is just maintaining the session. Now it's session, not the connection. It's just making sure that, so like if the other end sends something back, this is where they are getting back and forth and knowing where it did come from, where it's going to. Okay. But it's in general terms at this point of making sure the data's there, not in terms of the specific machine to there, because that's what we do down there on layers 2 and 3, and layer 1 where we physically send it. So this one's a very general layer, and it's almost like it's thrown in there just to confuse us. But it's forgetting that on the next layer going down, it's more concerned with that on it, but you don't always have, you're not dealing connections on this layer, you're talking about sessions, not connections. Sessions, just a general approach on it, but it's not the physical part. Okay. Well, there's a good reason it doesn't get its own chapter, as you notice how long it took in this chapter for them to cover session layer. They gave you what? 2 sentences, 1 paragraph is all they gave you. So I'm not even sure. Technically, it is a paragraph, but it's a short paragraph with just 2 sentences. And that, agreed, it's a run-on sentence in the first sentence. They were rather lengthy sentences. So there's not a whole lot on it. Biggest thing is remember those 3 terms. It establishes the session, maintains the session, and terminates the session. That's all you really need to remember about the session layer. Okay. And I'm not sure if I ever even had any certification questions on the session layer. I really don't remember any, but I could have. But if I did, there were very few. And even on a test, it's not much likely you're going to have much on it there. All right. So then they go into, from here, they talk about the application layer protocols. So notice we spent, what, 2 paragraphs? About 2 paragraphs on the presentation layer and about 1 paragraph on the session layer. And then the rest of the chapter is dealing with the protocols for the application layer. Okay. Most of these we've talked about before. And Whitfield, you get to hear about 1 protocol that I forgot to mention yesterday. So you get an extra little piece right here because I forgot this one to mention as we were talking through on it. So they go through and they talk about our models of networking again first. They mention peer-to-peer and client-server. And I don't know what they were thinking when they designed the book, but they got an error right here because they go to talk about peer-to-peer. And the very first thing underneath the peer-to-peer section as a subsection in it is about client-server. Well, there are 2 major models of networking. If you remember from back at the beginning of the book, was peer-to-peer and client-server. They're both out there. Client-server is where we got a server that basically keeps all your security information and all of that type stuff for all of the clients that are within that network. And those can be PCs, printers, cameras, IoT devices, whatever. But you've got a central one that's responsible for handling the request and everything. Biggest thing is it will also, the server can be as a file server, and so it keeps files on there that different clients use, etc. So you've got a server in the middle of everything and all the clients attached to it and getting information from there. Quite often in examples today, you'll see it talk about in terms of security, and about maintaining passwords, usernames, and all of that type stuff on there on that central one. Peer-to-peer says all of our machines are equals. There is no machine that has more stuff and maintains more about the network than the others. Each of the machines on a peer-to-peer network are responsible for their own security. They're also responsible for what files they're going to share, etc. And we've talked about this early in the book, but it may have gone partly over your head back then. And hopefully it makes some more sense at this point now. So you've got peer-to-peer networks out there. And Windows, when you set up and put a Windows machine on a network and then go to connect it with others, by default, it's going to go to a peer-to-peer network unless you're using the server software on it. It used to be that the professional software on it wanted to go to a client server, but now it still wants to go to a peer-to-peer by default, but you can only do a client server approach on computers, on Windows, when you're using the professional version of Windows and not the home version. The home version will only work peer-to-peer. Okay. Now, y'all can have machines running on the same network of that same network being both a client server network and a peer-to-peer network. For instance, my computer here in this office actually is sitting in a work group, which is what Microsoft calls peer-to-peer networking. And I think some of the other instructor machines actually have been set to share stuff with other machines on our peer-to-peer network or our work group, and that I can actually go get files from them. By default, everything's secured off, but sometimes you might want to, even in a client server, just share a file with another machine that's on your network without going through the server. And you can do that by also setting it up into the other way and sharing the file. Although if you're in a client server, you really want to stick client server. Now, peer-to-peer is used extensively out there also on other stuff. On the internet, there are peer-to-peer applications, and there is some stuff done peer-to-peer. Some of you sitting here listening to me today probably have done peer-to-peer and may not have even realized you were doing peer-to-peer network. Some things are set as peer-to-peer, and we actually do certain things peer-to-peer on it. And that stuff doesn't have to travel to a server and then to the other machine. Now, that's saying server. I'm not saying router. You'd have to use the routers and stuff to get along through the internet, but you're not having to go to a server that then determines if it's going to send it out and what it's going to do with it and all kinds of other stuff. Instant Messenger is an example of peer-to-peer, although where they're talking instant messenger really isn't there anymore. There's hardly anybody uses what's used to be called instant messenger. That you're using messenger services now, that you may well be using different ones on that out there. That you well use Facebook's messenger, and you may use and then you're liable to text also. But that was a peer-to-peer one on it. Should have been pulled out of this book when they wrote it, but I don't know how they left it in there, even though they changed the whole book around in sequence and everything else. Big place that some of y'all probably have used peer-to-peer networking is there are a number of games out there that work in a peer-to-peer approach across the internet. And so you connect to them, and they're not going through a server someplace. Some of your games do go through a server, and they keep up with all the stuff on you and all that stuff. But other games, you just connect with the other individual, and you play the game between the two of you, or three of you, or five of you, whatever it does, and that you do that on it. That's a peer-to-peer one. You didn't go through each of you to connect using information from some central server. So some of you may well have done or do that. Okay. Second thing with a peer-to-peer one, it just went out of my head again what I was going to say about it. In any event, there's lots of other things that will do peer-to-peer on it. They mentioned about texting as an example of a peer-to-peer application. They throw you a couple of games. eDonkey is one they like to mention for some reason, but throw you some on that. But with peer-to-peer, oh, I know what it was. If you're setting up a network, I said Windows by default likes to just set up automatically as a peer-to-peer network using work groups. And I think it usually actually assigns the name of the work group as work groups. You can change that, but you get to change it on every machine. Now, here's the problem with peer-to-peer. Each machine is responsible for its own security on that machine. So that means if I'm going to let Deidre connect in, that we're both on the same network, and I'm going to let her connect into my network, into my machine, I have to set up an account on my machine and a password for her on my machine, or my administrator can come do that. So assume I'm the administrator, and so I set that up on this machine along with on her machine. Now, she goes to change her password. It's going to have to be changed on my machine also. Now, that's fine up to that. Usually the definition is 10 machines is all you want on a peer-to-peer network. And I think Microsoft uses 10 to 10 as their magic number on it. Different vendors sometimes suggest slightly different on that, but you don't see any suggestion bigger than 15. 10 is usually the magic number suggested, and so you'll usually see 10 as the maximum size suggested for a peer-to-peer network. If you're going to go bigger, make it client server, which means you've got to buy a server and have a server in your network. And then you put all of your security stuff maintained on that security in a central spot. Now, if you got to change, Deidre wants to change her password. She changes her password. It doesn't actually change it on her machine. It changes it on that server, And that means then when she wants to connect to my machine at that point to get that file off my machine will check with the server to see if she met the security requirements to get to it. And that machine will provide a token for her. That means all we got to do is change her security information on the server. We don't have to go to each machine and change it on every machine because she needs to change her password, wants to change her password. She thinks somebody got a hold of it. Okay? So, and you can see where that number 10 comes in. If you've got 100 machines, you sure don't want to have to be going around as the system network administrator of when anybody on the network changes their password, you got to go change it on all of those machines because they may be using those different machines. You want it centralized so that you only have to change it once in there, or they can even change it to there. Because like I can change my password here at school at any time from any machine that I'm authorized on. And that makes it much faster. Does everybody follow that part about the differences in peer-to-peer and client-server? Because they do spend a decent little bit of time talking about those. Okay. Now, the rest of the chapter is looking at the protocols. So they talk about web protocols, and HTTP is your biggest web protocol that's used out there, Hypertext Transfer Protocol. We've mentioned that before. Y'all heard that probably before you were even in this class. And it's using the language that applications are normally written in that use HTTP are usually using HTML or hypertext markup language, although they can be using other languages also, although a lot of it is their embedded languages within the HTTP, like PHP, Python, and some others. And then they mentioned briefly HTTPS, which is Secure Hypertext Transfer Protocol, or Secure HTTP. The word secure comes before the words, but when you put the letter S on there for the name of the protocol, the S comes after on it. I don't know why they did that, but that's what they did. And remember on those. So I won't go much into that. Email protocols. There's 3 of those you need to be aware of. I believe we mentioned those in a previous chapter also to you. They talk about POP, SMTP, and IMAP. POP, you really don't have to know hardly anything about because POP's not really used anymore. It's rarely used, but it is still out there. POP version 3 is actually what we're on. So it's POP 3 is what you'll usually see it as. But we've been on POP 3 since somewhere back, since I've been doing stuff with email and stuff since back 95. We were POP 3 at that point, but POP only dates back to like the late 70s. So I'm not sure when 1 and 2 exactly appeared. POP is Post Office Protocol, and that is, it requires you to download your emails onto your machine, and then you read them on your machine. Originally, when you downloaded them, it erased them off the server. Then they gave you an option that you could tell it to keep them on the server, but you couldn't tell that you had read them or whatever from on there. That one's there. It is used occasionally when people want to pull all of their emails down to store on their local machine, besides them sitting out there on whatever server that they're using and that they use IMAP on. IMAP is a newer version used. IMAP allows you to keep the stuff on the server and you actually work with your emails on the server. It's Internet Mail Access Protocol. And so I can go in my email here on this machine, which I do every day, both my personal and school. And I can do changes out there. I can look at the mails. I can send mails. Everything's kept on the server. And it marks whether I've read it or not, etc. Then I can go home, get back onto the same account, and the emails will just like I left them when I've left the school. And that I can work with them all there. but they're not sitting on my machine at school. They're not sitting at my home machine, which with POP they did. So you've got full flexibility with it, and it gives you a lot of flexibility on looking at your emails and all of that. And I definitely want to finish for 3 because I got a seminar I was wanting to maybe listen to. I'm not sure if I'm going to really use it or not. SMTP is the protocol used to send emails, and that's whether you're using POP or IMAP. POP and IMAP is just for about how you're receiving and managing your emails. So that's the 3 of those. Then they talk about the IP addressing services. They talk about DNS. We have talked about it extensively before, but they talk about it again and mention about what domain name service or DNS does, which remember, you type in a domain name, dwightwatt.com, and DNS will get the IP address, which I don't even know what it is, of where my dwightwatt.com is stored. And that they remind you about how it goes through to do that. And that there's like 5 or 7 top level DNS servers, which is when you register a name, it actually is put out there. And then your local server uses a host file, and then there's a DNS server that you put into your setup that you tell it, if it's not in my host file, go to this machine. If it doesn't know, it goes to its DNS server and goes up a couple of levels on that, and then gets at the root level. And then when they do find something they don't know, they add it to all of the tables coming down. So it's very to the top level of the DNS server. And so they give you just a little bit on that one. Again, to give you a good bit on that one. NS lookup is a command you can use to look up and find out what your IP addresses are and stuff that's using DNS. So they throw you that command in here. Then they talk about DHCP. DHCP allows you to give addresses and all kinds of other information to your various client machines on your network instead of you physically setting them up on there. The name of the machine, the address, etc., can all be configured using DHCP because you can reserve certain things for certain specific machines using their MAC addresses. But DHCP says when you turn on the machine, it sends a discover request out because it doesn't have an address, and the discover goes out to all of the DHCP servers. Actually, it goes out as a broadcast, so every machine on your network hears it. The only ones pay attention to it is the DHCP servers. And then they send back an offer where they will send you, here's an IP address. And when I say you, I'm talking about the machine. The machine gets that back. Most of the time, you only got one DHCP server on a network, so there's only one address comes back. It is a broadcast. So any other machine on the network, all of them are going to see it and see what's being offered. If some other machine's using that address, which should not have occurred, but could occur, because somebody manually put in an address that's in the DHCP pool, which they shouldn't have done, that machine will respond back with a broadcast saying, no, you can't use that address because I'm already using it. So that reduces duplicate addresses on the network. Oddly enough, the network here at the college, there's apparently a machine somewhere on the network here at the college that has the same address as my machine, because about once a week I get notices from Windows telling me that my address exists already on the network, but the network's on around on it, and they say they have no idea where it is. So then with the client then sends back, after getting that offer, it sends back a request to the one with the address it wants to use. The server then sends back an acknowledgement that tells it that, yeah, I've got you marked in my stuff as you're using that address, and that machine starts operating using that IP address and any other information that the server sends to it at that point also that belongs with that address, like machine name, the DNS server, and all of that other stuff, subnet mask and everything else. So it can send a whole glob of information that then belongs to that machine. It's leased for 8 days by default. At halfway point, the server writes and says, do you want to renew the release? So that's working just like if you rented an apartment, except for if you rented an apartment or a storefront or whatever. Usually they don't come to you. It's halfway. It's usually more like they come to you when you're down to the last few months and see, are you going to renew or not? Or they do an automatic renewal and keep renewals until you drop it. So that's DHCP. Now, before DHCP, and I'm not sure why Cisco still keeps putting it in there, Boot P was used. Now, all Boot P, it worked similar to DHCP, except it was only for IP addresses. Now, Boot P will still be used if there's no DHCP server on this subnet. It will be used to point a DHCP request to another network. But Boot P is very seldom used nowadays, but Cisco keeps putting it in their books. And all it does is gets you an IP address. It was the early, very raw version of what became DHCP, which I forgot to mention that one yesterday. The simple reason, they tell you at the beginning of the chapter they're going to talk about it, and then they never mention it when they go to describing all of these protocols. The last two protocols they mention are both file sharing services. One, FTP is one of them. We just talked about that in the previous chapter some. Mentioned it there, and we've mentioned it before then. File transfer protocol, and remember an FTP program, which is actually file transfer program. So FTP uses FTP because file transfer programs use the file transfer protocol. Now, there are different versions of file transfer protocol that we mentioned a little bit of in the previous chapter or so, because we mentioned TFTP, which you would only probably use if you're transferring stuff to a machine directly connected, which you do sometimes to a router or switch. And Cisco has you use sometimes because there's no overhead on it, but you know it got delivered. Using regular FTP, you're relying on the protocol to make sure it got delivered. And notice there, that's making sure things got delivered. That's not doing a session. That's guaranteeing deliverance. And then there's SFTP also, which is a secure file transfer protocol, which goes into making sure that things are encrypted also. For FTP is not encrypting it when it sends it, but it's making sure it does get delivered. System server message block is another way you can use to transfer files. It gets mentioned quite often, but I've not seen much mentioning on test on it, but I have seen it pop up there, but not critical numbers of questions about it. And it's one that's out there that does get used. I've personally not directly used SMB, although some programs I use SMB. And that there is the chapter. Any questions on what all I just went over? Because we have run, it looks like, just about 55 minutes. And I'll tell you, next week we'll do 16 and 17. All right, that one is there. What Cisco stuck out there as a practice one that should be a practice in relationship to what your hands-on final is. Although I don't find it exactly real close to on it, but it is there and I've made it available to you that if you want to do on it, you can, but it's supposed to be some of what you're going to go through on your hands-on final, okay? And it's practice. All of the practice items out there do not count in your grade, but any practice thing that Cisco made available to you, I have put out there as a practice available to you if they've got a practice type thing for you. I've put them out there. Those of you that may be in 2601, Okay, I must have marked the block correctly on there. If I don't get it fixed in a little bit, William, send me an email to remind me, because I say I want to join this other session real quickly from CompTIA, and if it gets real interesting, I may forget what I've just said I'm going to do, but I'll go out there and get the practice final set correctly on it. All tests have been graded. Your test grade as soon as you finish taking the test. There is the module from last week that was due the 11th. There is a couple of people I have not graded yet, but there's just a couple. And that so those will be graded, and then if y'all had an assignment due yesterday, I don't remember if you did or not, I definitely have not started grading what's due this week. Now all of the resubmissions as of through Friday morning have been graded, and I think that was good through the weekend. I don't remember noticing in any class anybody resubmitting anything else that they had been allowed to resubmit, but something could have come in definitely since early yesterday afternoon, because yesterday afternoon I was at Whitfield Murray doing cabling with a couple of students from 4 o'clock till 7 o'clock last night. That's pretty much a 45-minute drive from here to there, and then for me back to Lafayette. So I was pretty much gone from 3 o'clock to 8 o'clock to go handle those. But I did do a little bit of grading while I was there. Test grades have appeared automatically in NetAcad, and I got to manually transfer them, and I'm going to try to start working on that in the next day or so, but I've been telling myself for 3 weeks I was going to do that. In either this class or 2601, I have created a number of the spots to put the grades out there at NetAcad for your assignments and discussions, but I don't have them all out there in that class, and I have not done them in the other class, I don't think yet, and I've got to create those before I can even transfer grades to Cisco. And then I'm going to try to move the test grades as quickly as possible to NetAcad, assuming I have your permission slip. Now, if you don't know if I have your permission slip or not, you can go into the grade book, and it is one of the first columns, first spots in the grade book, and y'all's is vertically, I believe is how it appears for y'all. It appears horizontal for me, but vertically for y'all, I believe. The last I looked, that was the way it was. And it's one of the first ones up at the top. And it says permission slip. Now, it's in the grade book there, but that does not count as a grade for you. So there are a couple of things in the grade book there that do not count in your grade. Permission slip being one of them. And there's a thing about your syllabus, extra credit, which 13% of people did. Is marked there too as a reminder to me, and I may have one other thing as a reminder out there, just as a reminder to me for a way to keep track of it. So but remember, your test grades automatically appear at NetAcad. Your assignment grades, as I get them done, appear in Blackboard automatically, and then I have to manually transfer them back and forth between those. So the discussions also automatically appear they appear once I grade the discussions, or I enter y'all's grades for doing the collaborating the discussion. Those will appear and do appear in Blackboard, and I have to manually transfer them to NetAcad. And I want to get that done as quickly as possible, but somehow I seem to have gotten way too many things to try to do right at the moment. And so I'm trying to keep things prioritized. Grading your assignments is a high priority. And grading the discussions is school requirement. So that one has to come before I even grade y'all's assignments. So I start with discussions each week, and I will get those last few things. I think there's only about 10 student assignments, student submissions from a week ago, from the 11th, that I still got to grade. and discussions are easier for me to grade here at school with my two monitors beside each other. At home, the monitors are on top of each other, and I don't look as well on that. Side by side looking makes more sense to me. And I don't know why I don't change them there at home, but it hasn't fit real well yet for me to do, and so I haven't done. Any other questions for me? If not, I'm going to let y'all go. It's 3 o'clock, or my computer says it's 3 o'clock, so I'm going to let y'all go. So I'm going to go ahead and stop the recording, and then I'm going to go join that 3 o'clock session. Y'all have a good week. I will see you next Tuesday at 2 o'clock. I don't think anybody else came in. I'm going to look at that real quick. 2, 3, 4. It looks like there is one other person joined us that I didn't get. Deidre Whitfield. Let's see who it was. Okay. William, I didn't have you down. So I've got you down now. All right. Now I'm going to. That was you. Now I got you on the list now. All right. So now I'm going to stop the recording.